I'm going to try to do 3 more problems. I'm going to try to do number 8, 11, and 20 on this video. And I'm going to talk less. I'm just going to work it out. But for this one, to complete the square, I first want to factor out a -1. And watch what happens when I do that. The 1 is going to divide to both sides, and when you divide 0 by -1, nothing changes on that side, leaving you with just x squared plus 6x plus, sorry about that, plus 11 equals 0. So now I need to make the space. So I'll have x squared plus 6x with a space. Bring the 11 to that side as a negative. You have to have it, square it, and then add it to both sides. So it's going to be plus 9 here, plus 9 there. X squared plus 6x plus 9 equals -2. So now I must complete the square. It's going to be x plus 3 squared. It's still -2. Next we need to take the square root of both sides. So now we have x plus 3 equals plus and minus radical -2. So you subtract 3 from both sides and you're left with x equals -3 plus or minus the square root of -2, which that is now going to become an imaginary number. So -3 plus or minus the square root of, let's get my cool pointer here, plus I radical 2, or -3 minus I radical 2 is your final answer, and that problem's done. So now let's zoom out. Let's look at the next part here. Okay, now if you read the notes from the textbook section, you would have seen what is called the discriminant. If we write the quadratic formula, you'll see what the discriminant is. We have x equals -b plus and minus the square root of b squared minus 4ac all over 2a. So the discriminant is in red. Whatever's underneath the radical is called your discriminant. So you'll be able to tell how many solutions they're going to be and whether they're real or non-real by what that discriminant turns out to be. So we're working on number 11 here. I'm going to show you how that works. So let's put the equation into its correct form. We got negative x squared minus 2/5 x minus 1 equals 0. Now we have our a, b, and our c. Let's write them down. Our a is in front of the x squared, that's -1. Our b, that's in front of the x, is -2/5. And our c is the constant number, which is -1. So from before, if our discriminant is b squared minus 4ac, remember that would have been underneath the radical symbol. So if we substitute, we would have -2/5 squared minus 4 times the a, which is -1, times the c, which is -1. -2/5 squared is going to be 4/25 because the negatives become positive. And now we have a negative times a negative times another negative. These two negatives turn out to be positive, and that will bring it back to being negative again. So we have a negative, and then 4 times 1 times 1 is just 4 again, so we have 4. Just to keep it fractions, we have 100 over 25 because that was 4 before. So when we solve this, and we do the math here, you'll end up with negative 96 over 25. Now, it doesn't really matter what the fraction is. The key is that this is a negative number. And we know from before this would have been underneath a radical symbol. So already we know we have imaginary roots. And there will be two of them because you have an actual number there. The only time you're ever going to have one solution is if you have radical 0. So keep that in mind as you move forward. That's the only time you're going to have one solution is when the discriminant comes out to be 0. But in this case we have two imaginary roots, two of them. Because in front of the radical would be a plus and minus. I know we have a 6-minute video so far. I just want to finish this up. We're going to try number 20. I'm going to do it as little talking as possible. Just get this done in a couple of seconds. We have to solve the equation by using the quadratic formula. And then you got to check your solution by substitution. I might leave this part out. We'll see what happens. Okay, here's our quadratic formula. Now let's identify the a, b, and c. But first we need to rearrange the equation so that we have an a, b, and c. So we have 2x squared minus 4x plus 7 equals 0. A, B, and C, we got 2, B is negative 4, and C is 7. Alright, now, this is important because this is going to come out to be positive 16. This is going to be a negative, because of that negative here. We got 14 times 4. It's definitely going to be bigger than 16, so we are going to have a negative number underneath the radical. You should be asking yourself, what does that mean about the roots? Well, this is going to be imaginary, so we're going to have imaginary roots. Let me show you how this radical negative 40 breaks down in this little bubble over here. So we have a radical negative 40, which can be broken down into radical negative 4 and radical 10. The radical negative 4, since there's a negative 1 in there, there's your I, and the square root of 4 is just 2, so that comes out to be just 2i. And then we still have the radical 10. That would simplify to 5 and 2, which don't simplify any further. So that's it. This just comes out to be 2i radical 10. Okay, now take a look. We have a 4 and a 2 and a 4. All of this is on the outside of the radical 10. These three pieces can all be simplified. And since the greatest common factor is a 2, you can take a 2 out of all three of these and reduce it down. Watch. The 4 becomes a 2, the 2 becomes a 1, and this 4 becomes a 2 also. So that's it. If you simplify it, this is your final answer. You have imaginary roots, because you have that I in there. It's irrational too, but that really doesn't matter. We have imaginary, and there's 2 of them, because you have your plus and your minus, so you have 2 of them. Or you could look at it as 2 solutions, 2 plus I radical 10 over 2 and 2 minus I radical 10 over 2. That's it. I'm done. See you guys tomorrow.